We're back, week 10, set 2, SWYK number 2. We're solving using that quadratic formula. So we're going to walk through this and do things kind of quicker than we have before, just because we have the hang of it now. So b squared minus 4ac, remember that's my first step, b squared minus 4ac. That's the discriminant. And in this case, I ended up with positive 69. And that value goes underneath the radical. And I have the opposite of b, plus and minus the square root of the discriminant, all over 2 times a. And Math Excel does want the answers to be split up. Now, could I write it like 7 over 2 plus the square root of 69 over 2, comma 7 over 2? Yes, you can do this. There's nothing wrong with that. Now, 69 does break up if you're trying to figure this out. 3 goes into it 23 times. Neither one of those is a perfect square. So, if you're trying to simplify the radical in this case, you can't. So, don't waste your time. All right. Next question. Scrolling. Keep them doggy scrolling. Sorry. I do have to distribute the 2x and then bring the 5 over to the other side. Because the quadratic formula, you can't solve it unless it's equal to 0. Then you can go through your discriminant process. b squared minus 4 times a times c ended up with positive 84. Now, there is a perfect square which goes into 84. That is 4, and it goes in 21 times. So I was able to break up that 84 into 2 radical 21. Now you're noticing that I split this one apart. The reason I split it apart was because you need to be able to look at these fractions and see how they reduce. And a lot of times kids make mistakes unless they split it up into common denominators and then simplify the individual fractions. I mean, there's nothing wrong with writing -1 plus radical 21 over 4 and -1 minus radical 21 over 4. Absolutely nothing wrong with that. It's just that a lot of kids make mistakes. They reduce one but not the other. So I like to split it apart like you see like that, and then we don't make as many mistakes. Next question. So question 3 here. Same old scenario, different question. Bring the 1 over. Now it's set equal to 0, so we can b squared minus 4ac. I ended up with 33. There's no perfect square which is inside of 33. So it is what it is. 5 plus radical 3 all over 4. 5 minus radical 3 all over 4. There wasn't any way to reduce that, so I didn't see. I mean, can you split it up into separate fractions? Sure you can. It's up to you what you want to do on that. Math Excel should take them both. Okay, on this particular question, didn't have to go too far. I pushed everything. You can see I pushed both of these things over to the other side. I like dealing with positive x squared terms. It's like a comfort food, I like it. So b squared, I know you think I'm weird. b squared minus 4ac ended up giving me, a negative number. Now, wait a sec. We're going to be putting that under the radical. The square root of -131 is the square root of 1 times the square root of 131. What? The square root of -1? Oh, I remember that from a previous lesson. That's the imaginary value I. Okay. So that's why you see me writing my answer like this. Now, 131, not a nice number. No perfect squares go into it. Leave it alone. So you can see my answers down here. I split it apart, but could I have written it just as 1, oops, I forgot the I, 131 all over 10. Yeah, we could have done it like this. -3 minus I radical 131 all over 10. Nothing wrong with it. Either way, doesn't matter to me. Next. Already set equal to 0. That's beautiful. B squared minus 4 times A times C. I ended up with a negative 16. Yes, that's going to go under the radical. Yes, we're going to get imaginary numbers, right? Because the square root of negative 16 is 4i. You notice that I split it up into 2 because I was going to reduce it, right? 3 plus 2i and 3 minus 2i. Why is that thing on the screen? I don't know. Okay, that's better. Question 6. Pushing everything over to the same side. Set it equal to 0. Opposite, or b squared minus 4 times a times c. We're finding that discriminant, and we ended up with a negative number. That's where that imaginary number stuff's coming in, because we know, oh, yeah, we can break this up into this. We know that's going to be under the radical, and so that's where we get the 2i and the 5, or radical 5, which you see right here. And then I broke it up into 2 parts. First fraction plus or minus second fraction, and then I reduced them to get my final answers. Like I said, you can leave them together if you want, but it's up to you, because when the things reduce, sometimes people make mistakes on reducing. Yes, quadratic formula is nice. It has to be set equal to 0. That's a given. And you can use it on any quadratic you want to solve. So in next week, we're going to talk more about when to use which method. And I think we can clear that out. I think we're done. Yes. All right. Get ready to do that SWYK and then move on to the assignment. And then you'll be ready for your test.